In this video, we are going to talk about section 9.3, and that's the p-value approach to hypothesis testing. Okay, so you might be wondering what happened to section 9.2. There are essentially two different approaches to hypothesis testing, and section 9.2 talks about the other approach to hypothesis testing. And so we're just going to skip that one and move on to section 9.3, the p-value approach. They pretty much do the same thing. You're just looking at it from a slightly different perspective in each section. So overall, you're not really missing anything by not doing it that way. The thing is if you later on are doing some research, you might see people in a research paper use the other approach, the critical value approach. Okay, and they're equivalent. Like I said, it's just slightly different. So, okay. So, but we're just going to focus on this p-value approach in our class. All right. So let's go over the outline of conducting a hypothesis test. These are the basic steps that you're going to do, and what we're going to do is just kind of refine these steps as we go along. So the first step is to state the null and alternative hypotheses, and then determine if the test is two-tailed, right-tailed, or left-tailed. So these two steps, basically we talked about how to do that in section 9.1, okay? In section 9.1, we had some problems where you had to state the null and alternative hypotheses and then determine if it's a two-tailed test, a right-tailed test, or a left-tailed test, okay? That's if you haven't watched that video, you need to go back and watch that. We're not going to focus on that part of the hypothesis test. What we are going to do instead in this chapter is add a little bit more detail into this step here. So after you do those first two things, right, back in section 9.1, we talked about, hey, you're going to have to make a decision as to whether the null hypothesis should be rejected in favor of the alternative hypothesis, okay? And that's going to come down to one of these two things. You're either going to reject the null hypothesis in favor of the alternative hypothesis, or you will not reject the null hypothesis in favor of the alternative hypothesis. So that is what we are going to talk about in this section 9.3. How do you make this decision? Okay, so that's what this section is all about. So we won't talk a huge amount about the first part. We already did that. We're going to talk about how do you make this decision. Okay, and then the thing that you want to do after you make the decision is to interpret the results of the hypothesis test, and this is pretty much the two things that you will decide on. If you reject the null hypothesis, you conclude that the data do provide sufficient evidence to support the alternative hypothesis. Okay, so you would say, hey, the null hypothesis is not true. We've got some evidence to support the alternative hypothesis. And then if you do not reject, right, then you conclude that the data that you've got, the sample that you took, does not provide sufficient evidence to support the alternative hypothesis. Okay, so that's really the interpretation. So again, we're not going to focus much on this last step or the first two. This section, right, in 9.3 is going to be about how do you decide whether to reject or not reject. Okay. And then in sections 9.4 and the last one, 9.5, we will put all of this together. Okay, and we'll do problems where we do all of these steps. All right. Okay. So the first step in how do you decide, we need to talk about the significance level. And the significance level, it'll be denoted by alpha. Okay. So the significance level of a hypothesis test is the probability of making a type 1 error. And if you haven't watched the section 9.1 video about type 1 and type 2 errors, you probably should go back and take a look at that. But a type 1 error is when you reject a true null hypothesis, okay? And so the significance level is usually specified before the hypothesis test is conducted, okay? And so you're just going to agree, you're doing some research, right? And you're going to agree on this level, right, significance level. And basically, that's going to represent how willing you are to make a type 1 error, okay, that you would reject a true null hypothesis, all right? And so typically you'll see, significance levels of 5%, so that would be 0.05 as a decimal, or sometimes you'll see 0.1 or 1%, 0.01, or 10%, 0.1. Okay, and so again, that is generally agreed upon before you do the test. So when you read these problems, you'll just have to pick that out. You won't have to decide yourself, what the significance level is going to be. Now, if you're doing your own research, right, you have your own research project that you're doing, in a class later on, when you are a junior or a senior, right, then you might have to decide, but 5% is a really common one, and you would have to just get with the professor that you're working with and decide what level that you are going to agree with. All right, and then I say here, you might say usually specified. By that I mean sometimes you'll read a paper where they don't say the significance level ahead of time. They'll just show what's called the p-value, which we'll talk about next, and then they basically let you decide, based on the p-value, how strong their results are. Okay. All right, so just as an example of how this would appear in a typical problem that will work, right? We have this example. It says data on salaries in the public school system are published annually in Ranking of the States and Estimates of School Statistics by the National Education Association. The mean annual salary of public classroom teachers is $55.4 thousand. A random sample of 90 classroom teachers in Ohio was taken, and I've omitted the data to save some space. It says at the 5% significance level, right? So they're just going to come out in these problems that we're working in the book and flat out tell you what the significance level is. So it's not like you're deciding, right, what that level is, all right? Okay, and so then it goes on, right, to ask, do the data provide sufficient evidence to conclude that the mean annual salary of a classroom teacher in Ohio is greater than the national mean, right? So you would get the null hypothesis, the alternative hypothesis, and decide if it is a one-tailed or two-tailed test, and then note, right, the level of significance right here. It's 5% significance level. So again, right, that is the probability, right, that when you run this test, you are going to reject a true null hypothesis, make a type 1 error. And you want that to be low, right? You don't want to make that type of error, okay? But again, right, there's always going to be some, you can't get 0% error, right, in this in this hypothesis testing, because we are always operating from a sample, so partial data as opposed to population data, okay? All right. So that's the significance level. Again, it's normally just given to you. All right, so now the part that's not given to you generally is what's called the p-value, okay? So the p-value of a hypothesis test is the probability of getting sample data at least as inconsistent with the null hypothesis, and therefore supportive of the alternative hypothesis, as the sample data that you actually obtained, okay? So that's a mouthful right there. What is that saying? Well, first off, right, the p-value is going to be a number, right? It's a probability, so that means it's a number between 0 and 1, right? And remember, 0, right, if an event has probability 0, then it's impossible for that event to happen. If an event has probability 1, right, then it's going to happen. It's 100%, right, going to happen. So the closer your p-value is to 0, the stronger the evidence is against the null hypothesis, okay? And hence in favor of this should say alternative hypothesis, okay, right there. So let me fix that typo. So that number that you get, the p-value, right, basically is telling you how rare that sample would be that you got from coming from the population with the null given null hypothesis that you are conducting there. All right, let me fix that typo really quickly here. So when you take a sample, right, you have, a couple of things might happen. Number one, right, when you take that sample, you might get a sample mean that is pretty close, right, to the population mean. Okay. Oops. You might get a sample mean. You take your sample and you get a mean that's really, really close to the population mean, right? And to whatever the null hypothesis says, right, is the population mean. Well, then that doesn't really give, that that kind of suggests that, probably the null hypothesis is true, and you would not reject it in that case. On the other hand, maybe you take a sample and you get a sample mean that's a lot different, right, from the population mean. So what you can do, right, so that sample mean that's a lot different than the population mean would be inconsistent, right, with the null hypothesis. And so that means probably that the alternative hypothesis, right, is more likely. And so that p-value represents the probability that you would get a sample like the one that you took, or one that's more inconsistent, right? So in other words, if I got a p-value of 0.5, right, that would say that, well, the null hypothesis is probably true, right? In other words, the probability that you would get a sample like that, or one that's worse, is about 50% of the time. That's half the time, right? So that really doesn't give a whole lot of evidence to support the alternative hypothesis over the null hypothesis. On the other hand, right, if you take and calculate your p-value and you get a p-value of 0.01, right, that would say that, yeah, that is pretty strong. That's a rare sample. That really shouldn't happen a whole lot of times when you take a, if the null hypothesis is true, right? So the closer that value is to 0, the more likely it is, right? And again, it's still a probability, still not guaranteed, right? But the more likely it is that the null hypothesis is not true, right? And then we would reject it, okay? All right, so that's what the p-value is. So what we're going to do, right, the decision, how you make your decision is, what you're going to do is calculate this p-value, and we'll tell you how to do that in just a second, okay? How to calculate the p-value, and then you're going to compare it to the significance level. If your p-value is less than or equal to the significance level, you're going to reject the null hypothesis. If the p-value is greater than the significance level, you do not reject the null hypothesis, and that's it. All right, so the question we hadn't answered before is, how do you decide, right? Well, now here is telling you how we're going to make these decisions about whether to reject the null hypothesis or do not reject the null hypothesis. We're going to calculate this p-value. I'm going to show you how to do that in a minute. And then you're going to compare that p-value to the significance level. Remember, that's going to be given to you, all right? If the p-value is less than or equal to, right, the significance level, well, then that is pretty good evidence, right, that that the alternative hypothesis is the one that's true. So you're going to reject the null hypothesis in favor of the alternative hypothesis. If the p-value is greater than the significance level, then that we're going to say that's not good enough evidence, right, to reject the null hypothesis. So we are not going to reject the null hypothesis in that case. All right, so that's all there is to it. So that leaves us one thing left, right, in order to make the decision is, okay, well, how do you calculate the p-value? And that's what we're going to talk about next, and that's what the homework problems in this chapter are basically a small part of the hypothesis test. And it's that decision-making part, whether to reject the null hypothesis or do not reject the null hypothesis. Okay, so we're going to talk about how to determine the p-value for one specific type of test. Okay, and that's going to be the one mean z-test. And this is related to the one mean confidence interval, z confidence interval, that we talked about in section 8.2 in our book. Okay. All right. You can use this procedure for hypothesis testing to calculate the p-value when the population standard deviation is known. Okay. And the variable under consideration is normally distributed. All right. Okay. So our null hypothesis looks like this, right? Mu equals mu naught, which they're all going to look like this, right? For the ones that we're doing. Okay. So the first thing to get the p-value, what we would do is calculate the test statistic, and that's z. That's the same z, right, that we were using before. Okay. And so this should look pretty familiar to you, right? We did this in section 7.3 when we were calculating probabilities related to sample means, okay? All right, and so that's what we would do. We would have our sample mean, that's x bar. Mu naught is the number right here in the null hypothesis. Sigma is the population standard deviation. And then divide that by the square root of n, right? That is the sample size. So we would calculate this out, and that would basically give us the z-score, right, for our sample mean if it came from a population with this population mean, mu naught, okay? So essentially, we are just calculating the z-score of this sample mean, all right? And so that, again, that is exactly the same kind of stuff that we were doing back in section 7.3. Okay. All right. So the next step, right, to getting the p-value is going to depend on whether the test is two-tailed, left-tailed, or right-tailed. Right. Remember, if you haven't watched the video for 9.1 about how to determine that, it just comes from the alternative hypothesis, and it's very simple. There's 3 different alternative hypotheses that we talked about, and it's just going to be from the form of that. Okay. All right, so let's go over those 3 things. All right, so first, the p-value for a two-tailed test. Okay, so the p-value is the area under the standard normal curve that lies outside of the interval from minus the absolute value of z to the positive absolute value of z. So that might look a little strange at first, but it's not nothing to be worried about, because basically, when you calculate this z, right, we calculate the test statistic, you calculate this z out, then that z could be a positive number, it could be a negative number, okay? And so that's why we're talking about this absolute value here, right? So if you calculate the z and it's a negative number, then it will be this over here, and this one over on the right will just be the opposite of that. And then the other possibility is you calculate the value of z and it's a positive number. Well, the positive z obviously is going to be over here, right? And the negative one is going to be over here. So that's the only reason for the absolute z and minus absolute z. And don't forget, we're talking about the standard normal curve here, so 0 is right in the middle. So all the positives over here, negatives over here. All right, so all the p-value is, right, in the case of a two-tailed test, is the area over here to the left of the negative version of the z-score, and over here to the right of the positive version of the z-score. Okay. All right, and then all we would do to calculate the p-value is use table 2 to find this area over here on the left side of the minus, the negative z-score. Okay, and then times that by 2, because we know that the graph of the standard normal curve is symmetric, right, about the mean right here. So this area over here on the left is exactly the same as the area over here on the right. So we would just times that by 2 to get the area of both combined. And of course, we would look up the one for the negative because that's just a lot easier using table 2. Okay? All right, so that's it. So this really kind of reduces down to a problem from 6.2. Okay? All right, next up is the p-value for a left-tailed test. All right, and so the p-value for the left-tailed test is just the area under the standard normal curve to the left of your z-score. All right, and that's whether it's positive or negative. You only have to worry about 2 z-scores in the two-tailed test. So for this one, right, we calculate our test statistics. We're going to get a z-score. We want the p-value is going to be the area to the underneath the standard normal curves to the left of that z-score, right? And so we just looked that up in table 2, and that's the p-value. That's it. Okay. All right. And next up is finding the p-value for a right-tailed test. All right, so the p-value is the area under the standard normal curve that lies to the right of the z-score, again, regardless of whether it's positive or negative. Okay, so we're finding the area to the right of that z-score. All right, and again, this boils down to one of those problems from 6.2, right? If we want to find the area to the right of the z-score, then we just look up the negative of that z-score, right, in table 2. So again, the formula for it's going to be the absolute value and then the opposite of whatever the z-score is. In other words, if your z-score is negative, you can just look it up in the table, right? You don't have to do anything. And then do 1 minus whatever that is. If your z-score is positive, right, then you look up the negative version of it, okay? And then subtract that from 1. That's going to give you that area over here, okay? So we want the area to the right. All right, and in each case, that's going to give us the probability that our sample mean would be whatever the z-score was or above. In the case of the left, it's going to give us the probability that our sample mean is at whatever the z-score is or lower than that, right? And in the two-tailed test, right, it will be above this one or below this one. All right, so that gives you the probability that you would get a sample like the one you got or one that's more inconsistent, right, than the one that you got. All right. All right, so that's the procedure. All right, let's take a look at this example right here. Okay, it says the value of the test statistic for a two-tailed one mean z-test is z equals 2.24. Okay, so we're doing a two-tailed test. Yeah, let me draw the picture here so I can take a look at it. .24. All right, so that's what we're given, right? And this is a two-tailed test, right? So the picture for a two-tailed test, we're going to look at minus 2.24. So our p-value in this case is going to be this area right here, okay? All right, so what I'm going to do is to look up minus 2.24, a z, right, of that in table 2. All right, so let's do that. And just give me a minute. I should have done this before, but I did not. All right, so I'm looking up minus minus 2.24. So that's right here. All right, and then 0.04 is right here. So I'm looking at this number right here, which is 0.0125. Zero point 0.0125. All right, so that's the area of this little piece right here. Because we know that the standard normal curve or any normal curve, right, is symmetric about the mean, that means we know that the area of this piece over here, right, is also 0.0125. So that means that our p-value is going to be 2 times 0.0125, okay? And so that comes out to be 0.025, right, when we add those two together. Okay? Okay, so that is part 1, part A, the p-value. It's 0.025. Okay. And so next up, right, it says at the 5% significance level, do the data provide sufficient evidence to reject the null hypothesis in favor of the alternative hypothesis? Okay. So what we're going to do is take that p-value, right, in part B, we have 0.025, right? And we're going to compare that to the significance level, which is 5%, which is 0.05 as a decimal, right? So again, they tell us that it's at the 5% significance level. All right? So we are going to decide, hey, which one of these two numbers is bigger, right? Okay? So in this case, we see that the p-value is less than, right, the level of significance. And so that means, right, that we are going to reject the null hypothesis H0, right, in favor of the alternative hypothesis. Okay? All right, and so that's how we are going to make the decision, right, for this two-tailed test. All right, so in this case, again, just to kind of reiterate, right, this sample, we didn't see the data or anything or calculate the mean. They just gave us the z-score, right? But the z-score, right, was 2.24, right? And so what that means is that this sample that we took, right, the probability that we would get a sample that's that inconsistent or more inconsistent, right, is 0.025, assuming that the null hypothesis is true, right? So that's pretty rare. It's rare that you would get a sample like that if the null hypothesis was true, right? And this is the cutoff, right? The level of significance, we're saying, hey, if we get a probability less than this alpha, then we're going to say, hey, that's rare enough that we're going to reject the null hypothesis and go with the alternative hypothesis. All right, so that's the significance of that. Okay, so just revising our outline of conducting the hypothesis test with our new information, right? These are the steps that we're going to run through. We're going to state the null and alternative hypothesis, determine if the test is two-tailed, right-tailed, or left-tailed. Remember, that is stuff that we talked about in section 9.1, okay? Not in this video. Once we do that, we are going to decide on the level of significance, alpha, right? And again, for us, that's just going to be given to us. You know, if you're doing your own research, then you would decide, all right? And then calculate the test statistic, all right? That's that for the one mean z-test, it's going to be z equals x bar minus mu naught divided by sigma divided by square root n. Okay, so that's the calculation of the test statistic. Next up, we're going to determine the p-value. All right, so these are things that we are practicing here in this section. And then based on that, we're going to make the decision as to whether the null hypothesis should be rejected in favor of the alternative hypothesis. And the criteria, right? If the p-value is less than the level of significance, then we're going to reject the null hypothesis in favor of the alternative hypothesis. If the p-value is greater than the level of significance, alpha, then we do not reject the null hypothesis in favor of the alternative hypothesis. Okay, so that is the process, right, that we are going to run through. All right, and then finally, interpret the results of the hypothesis test, right? And you can just use these statements, right, if based on whether you reject the null hypothesis or not. So that part is pretty straightforward. All right, we have some example problems. I'm going to split those out into separate videos. And then the homework problems here are 9.63 to 9.67 odd. Again, these problems are just small parts of hypothesis tests. And then in 9.4 and 9.5, we'll start putting everything together and doing full hypothesis tests. All right, that's it for this video.